So Fabric failover is available today. It's been available since UCS FTS, ever since the 1.0 release. Now, how it works is relatively simple. You create a VNIC, and when you create a VNIC, you just say, please enable failover on this VNIC. And what that essentially does is that as that VNIC gets exposed to the host operating system, you don't have to, and our customers don't have to bond these drivers or use NIC teaming on these drivers. If anything in the network fails within UCS, this on the Fabric A, where this traffic might be headed from this VNIC, the VNIC automatically goes over to Fabric B. So the host OS is completely unaware of this failure in recovery. You don't have to use NIC teaming. Redundancy can be provided with a single interface, and we take care of the fact that no traffic gets black hole upstream in the aggregation layer because we transmit a GARP and we do multicast group re-registration after this failover. So significant advantages in a UCS environment. Our customers, unless they really want to for some other system level reasons, they shouldn't have to do things like NIC bonding and NIC teaming. They should be able to use just Fabric-based failover. Now, virtual environments, you've got several other rich choices. You can certainly use the internal soft switch failover capabilities, which continues to be our recommendation. So now let's talk about the enhancements as compared to 1.3. What were the enhancements that came out in 1.4? So there's some details around Fabric failover I threw into the slide deck. I'm certainly not going to cover it here. You're probably more familiar with it than even myself. But the one thing I do want to point out is the difference. What was the net new thing that was introduced in 1.4? So in 1.3, if you had a bare metal environment, for instance, and a single host operating system was talking, a single MAC-C in my environment was talking on ETH0 and ETH1, and failover was enabled. Let's say there was a failover on the left fabric here in my example. If there's a failover on the left fabric, the traffic gets automatically shifted over to the right fabric, and in addition to that, we send out the GARPs and appropriate notifications and multicast read registrations to the aggregation layer, so that the aggregation layer up at the top of my picture here knows that now to talk to MAC-C here, I don't send the traffic incoming from the rest of the LAN down this pipe, because this pipe is broken. I instead have to send traffic down this pipe. So this is the world as it was in 1.3. In 1.4, things changed quite a bit. We enhanced this feature quite a bit so that now, not just for bare metal environments, but for VMs, we can do this. So if you've got on that particular UCS server several VMs, and I've shown just one here, MACD, we learn those MAC addresses within the Fabric interconnects, and we know that these belong to certain virtual machines coming out from this particular UCS server, so that if there is a failure, the aggregation layer, which is now talking on this link, we can tell the aggregation layer. So if there's a failure here, we can take that traffic, send it over to the other side, and then generate a GARP for this virtual machine as well, which is not something we were doing before 1.4. And let the aggregation layer know, so the aggregation layer now, instead of talking on this link down to this device, now starts talking on the other link and on to the other fabric to talk down to the VM. That is important. That is key. And it's key because it's important in Hyper-V. Not necessarily in in VMware-based environments, because that internal soft switch, be it a vSwitch or be it Nexus 1000V, already offers a very rich set of HA capabilities, so you don't really need Fabric failover in that sort of environment. And that continues to be our recommendation. If you're using ESX, then we continue to believe that they offer a very rich set of HA capabilities. Fabric failover is not necessarily something that you would need to configure in that sort of environment, so the current recommendation stays. Now in Hyper-V, the interesting thing is Hyper-V does not support NIC teaming or bonding. You would require a third-party intermediate NIC teaming driver to offer software-based network link HA, and that officially is not supported by Microsoft technical support. So there's some issues around how exactly do you configure HA in a Hyper-V environment. And guess what? The enhancements you make to Fabric failover totally take care of that. Because what that allows us to do now is that VM could be a Hyper-V VM or any other VM. We don't really care, because what's happening is, as that VM is configured, now in a Hyper-V environment, you can just expose that VNIC, let's say from a virtual interface card from Palo, directly into the Hyper-V vSwitch, and then as the path on one side fails, we generate the appropriate notifications to the aggregation layer, and that takes care of the Hyper-V redundancy situation. So significant advantages around Fabric failover for bare metals. Those are always been there. In a virtual environment with VMware, you've always had an excellent solution with a Nexus 1000V or a vSwitch, and now with Hyper-V, where there was a little bit of complexity that our customers were forced to sort of undertake, we've taken that away off the table as well. So if your customers want to, in a Hyper-V environment, we offer the absolute best HA capabilities because unknown to Hyper-V, unknown to the VMs that are running, we can transparently switch traffic from failed links to working links as the failures happen, and we can let the aggregation layer know as well so there's no black holing of traffic.